Hi viewers, this is M. Samahadri, lecturer statistics. Today video I am explaining important theorem in simple random sampling. Right. So what is the theorem? What is the important theorem? Most very important theorem in this chapter. So what is that? That theorem statement is in usual notation so that variance of y bar and SRSWOR, and that means in simple random sampling without replacement, the variance of sample mean is equal to n minus n by n into s, right? Otherwise, or variance of y bar and SRSWOR, that means simple random sampling without replacement, in variance of sample mean is equal to 1 by small n minus 1 by capital N into s, right? This is the theorem statement. I'm explaining the proof of this theorem. So what is that? Very simple. First we take the population information, and next you can take the sample information of this theorem. Right. The first one is if small y1, y2, and so on yn be the n population units. So I'm taking the first of all population. The population size is capital N. The units are y1, y2, and so on yn. Right. I'm explaining. Write down on now. I'm writing the formulas of population mean. Means first of all write the formula population mean yn bar. What is that? 1 by n summation running from 1 to n ya. What is the mean formula? Mean is adding of all the observations by total number of observations. So adding of all population units y1 plus y2 plus and so on yn means summation running from 1 to n. Okay, yi. Total number of observation size is capital N. So 1 by n, that is the population mean formula. Next one is population variance. What is that? Population variance sigma square is equal to 1 by capital N summation running 1 to n ya minus yn bar whole square. This is the population variance formula. Next one is population mean square. What is that? 1 by n minus 1 summation running from 1 to n ya minus yn bar whole square. Population mean square. Next, you can take the sample to the population, that is let y1, y2, and so on yn, small y1, y2, and so on yn, be a sample of size small n taken from the above population with SRSWOR. Okay, using simple random without replacement, take a sample to the population. Population observations are y1, y2, and so on yn, and the sample size is small n. Right, and write the sample information. Next one, write the sample formula. Sample mean yn bar is equal to 1 by n summation running from 1 to n yi. This is the sample mean yn bar formula. Next, you know that the condition of the simple random sample without replacement, the sample mean is unbiased estimator of population mean. And this is the condition, that is expectation of small yn bar is equal to capital yn bar. Already, you know the concept of simple random sampling. The sample mean is unbiased estimator of population mean in SRSWOR. That is expectation of small yn bar is equal to capital N. Now I am taking now LHS variance of yn bar. So what is the statement? Variance of y bar n is equal to n minus n by n and s square. We have to prove that variance of y bar n is equal to n minus n by n into s square, right? So I am taking LHS first of all. Variance of yn bar is equal to. Now the variance formula in expectations. So variance formula in expectation, what is that? Variance of x is equal to expectation of x minus expectation of x whole square, right? Already you know the formula, right? In the place of x, yn bar. So variance of yn bar is your expectation of yn bar minus expectation of yn bar whole square. This yn bar minus what is that? Expectation of small yn bar is equal to what is that? Capital yn bar, and the capital yn bar whole square. Equation number 1. Now I am taking one of the condition, summation running from 1 to n small yn bar minus 1 by capital N bar. So this is assumption of this theorem. Summation running 1 to n small yn bar minus capital N, but that is equal to yn bar is a constant value and capital N bar is a constant value. So subtract of the two values is again constant value. So this is a constant value in summation. So usually n times of summation constant, right? N into small yn bar minus capital N bar, right? So n into small yn bar minus 1 capital N bar is equal to multiplication n in two terms. So n into small yn bar minus n into capital N bar. Now n by n bar. What is n by n bar? Very simple. You can take the sample mean formula. By n bar is equal to 1 by n summation yi. This is the sample mean formula. If you want summation yi, so this is what is that? N into yn bar. Okay, n into yn bar is equal to what is that? Summation yi. So n into yn bar is equal to summation yi, right? N into yn bar. It means yn bar plus yn bar and so on yn bar n times. Yn bar n times, right? So now expand this summation yi, y1 plus y2 plus and so on yn minus of yn bar plus yn bar plus and so on yn bar, and subtract take a first term and this first term y1 minus yn bar plus y2 minus yn bar plus and so on yn minus yn bar. The concept, right? Now squaring on both sides. Now writing squaring on both sides. Squaring on both sides. What is that? This is n square into n square into what is that? Small yn bar minus capital yn bar whole square. Okay, n square into small yn bar capital yn bar whole square is equal to what is that? Y1 minus yn bar plus y2 minus yn bar plus and so on yn minus yn bar. Okay, this is whole square. Now this is a plus b plus c and so on whole square formula. Right? A plus b whole square visually. A square plus b square plus 2ab. First I'm writing y square terms. Y1 minus yn bar whole square plus y2 minus yn bar whole square plus and so on plus yn minus yn bar whole square plus I'm writing next to a square plus b square plus 2ab term. So 2ab terms 2 into y1 minus yn bar into y2 minus yn bar. Okay, plus and so on, right? So this is the concept. Now that is equal to what is that? This is y1 minus y2 this is y1 minus yn bar whole square plus y2 minus y1 whole square. This can be also written as summation. Take a summation symbol. So all adding the terms. Okay, summation I running from 1 to n 1 to n 1 to n. What is that? yi minus yn bar whole square, right? Plus this one is 2ab terms. That means 2 into I'm taking double summation, right? What is that? Summation I not equal to j equal to 1 to n, right? yi minus yn bar into yj minus yn bar. So in this case I are not equal to j. For example, for suppose I equal to j, then for y equal to yi, this is square term. So automatically y1 minus yn bar whole square, y2 minus yn square, like these terms. So it is strictly I not equal to j is equal to 1 to n, right? So what is that? N square into small yn bar minus capital yn bar whole square, right? So now taking expectation on both sides. Taking expectation on both sides. Take expectation on both sides. What is that? So n square into expectation of small yn bar minus capital Yn bar whole square is equal to what is that? Expectation of summation I running from 1 to n yi minus yn bar whole square plus 2 into expectation of double summation I not equal to j is equal to 1 to n. So ya minus yn bar into yj minus yn bar. Right? The expectation. Now, what is that? This is n square into by using 1 expectation of small yn bar minus expectation of y. This is expectation of yn bar. Okay. Finally, this is variance of yn bar. So from 1. Okay. Already you know the concept. See this equation number 1. Variance of yn bar is expectation of small yn bar minus capital yn bar whole square. So this is variance of yn bar. Right. This is the variance of yn bar. Right. Next. That is equal to. This is the most important step. Observe that expectation of summation I running from 1 to n yi minus yn bar whole square. What is this? So see the our last video we had to discuss the point. I show you. Observe that this is one of the important point. Note expectation of small yn bar is equal to capital yn bar, and substituting small yn bar formula, and this is capital yn bar formula, and on simplification apply the expectation to variables. So on simply last step is expectation of summation I running from 1 to n yi. Expectation of summation I running from 1 to n yi is equal to what is that? Small n by capital N into summation I running 1 to n yi. And in the writing in the place of expectation of summation yi is equal to write that n by n into summation I running from 1 to n yi. Okay, it's there. Using this concept, observe that expectation of summation yi. Expectation of summation yi. Right? So what is that? This is n by n. This is n by n summation I running from 1 to capital N. See the note. Okay, 1 to capital N. What is that? Capital yi minus capital yn bar whole square. Right? This is the concept. Plus next one is 2 into n by n. This is the one I summation, and next is j summation n minus 1 by capital N minus 1. This is the j summation. So write that double summation I not equal to j is equal to 1 to n. So this is capital yi minus yn bar, capital yj minus yn bar. Okay, this is the very important step. Okay, so don't confuse using that above concept. Then this means note. Okay, previous class we have discussed the previous video we have discussed the concept. So expectation of summation yi is equal to n by n into summation I running on to capital N yi. Right? So using this concept, you write n by n into summation I running on to capital N for capital yi minus yn bar whole square. Usually these are remaining terms. The remaining terms. Right? So that is equal to what is that? This is equal to n by capital N into. So you have to observe that formula population mean square. Okay, what is the population mean square formula? See this. What is the population mean square? This is the population mean square formula. What is that? Summation I running 1 to n yi minus yn bar whole square is equal to n minus 1 into s square, right? N minus 1 into s square is equal to n minus 1 into s square is equal to summation I running 1 to n yi minus yn bar whole square. Now see this concept, summation I run 1 to n yi minus yn bar whole square is what is that? N minus 1 into s square, right? N s square plus this is small n by capital N into n minus 1 by capital N minus 1 into what is that? See this this is 2ab term. See, observe the point. So I'm giving for example a plus b whole square is equal to a square plus b square plus 2ab formula. We want 2ab term So automatically a plus b whole square minus of a square plus b square, right? And this is the formula to a better a plus b whole square minus right whole square minus a square my a plus b whole square minus a square plus b square, right? So using this concept, apply this theorem. So this is a 2ab term, right? 2ab term. So I'm writing 2ab term. So first one is a plus b whole square. Okay, what is that? Summation I running, sorry, okay. So first one is y1 minus yn bar plus y2 minus yn bar plus and so on yn minus capital Yn bar. Okay, so this is the concept. This is whole square minus a plus b whole square minus minus a square plus b square, right? A square plus b square means y1 minus yn bar whole square plus y2 minus yn bar whole square plus and so on plus yn minus yn bar whole square. And this is the concept. Okay, so now I'm writing that this is the same term, right? The same term. So this is, what is that? N by capital N into n minus 1 into s square plus this is same n into n minus 1 by capital N into n minus 1. So observe that this into, observe that, so what is that? A plus b plus c whole square. That is what is simply you can say that summation I running from 1 to n. Okay, so this is yi minus yn bar. Okay, observe that this is whole square. It's very important bracket. It's a whole square minus what is this? Summation I running from 1 to n. So yi minus yn bar, this is square, whole square. So this is summation x whole square minus summation x square. The entire different terms, two terms. Okay, so this can be all written as summation I run to n y minus yn bar whole square. This is summation I running on to n y minus yn bar whole square, right? So now simplification, that is equal to same 1 by capital N into n minus 1 into s square plus n into n minus 1 by capital N into n minus 1. So minus 1, this is 0 term. Okay, minus summation running from 1 to n y minus yn bar whole square, right? This easily, this can be written as simply n minus 1 into s square. Simply you can write that this is n minus 1 into I square. This is term 0. What is that? The term, right? I'm explaining this concept. The term summation I running from 1 to n y minus yn bar equal to 0 because the algebraic sum of the deviations, sum of the deviations from their arithmetic mean is 0. What is that? The algebraic sum of the deviations from their arithmetic mean is 0. Okay, you know the concept of this is that the concept summation x minus x bar is equal to 0. Okay, because I running from 1 to n, x minus x bar is equal to 0. You see that summation I running from 1 to n xi minus summation I running from 1 to n x bar. Okay, that is equal to that is equal to this is the nx bar minus this is the nx bar is equal to 0. Simply. This is the concept. So the ya minus this is mean. Okay, ya minus y bar n bar is equal to 0. So the term is 0. So this is 0. So finally that is equal to small n by capital N into n minus 1 into s square plus this is plus minus minus, right? N into n minus 1 by capital N into n minus 1 into what is that, n minus 1 into s square. Right, is equal to small n into capital N minus 1 by n into s square common to all the terms. This is 1 minus, okay, 1 minus what is that, small n into n minus 1 by, that means remaining is n minus 1 divided by n minus 1, right? N minus multiplication, n into n minus 1 by capital N into s square. What is that LCM? N minus 1 LCM is n minus 1 minus n plus 1, right? So plus 1 minus 1 cancel in the bracket, and finally n into n minus 1 by n into s square. The denominator value n minus n by n minus 1, right? This is n minus 1 cancel, right? And finally n into n minus n by capital N into s square. Is that this is n square into variance of y bar, but we want variance of y bar n only. So variance of y bar n is equal to, what is that, n into n minus n by n into n square into s square, right? So n cancel, and finally n minus n by what is that, n into s square. Therefore variance of yn bar equal to n minus n by nn into s square. The variance of sample mean in simple random sample without replacement is n minus n by nn into s square. Okay, this is the very important theorem this semester examination, right? In simple random sampling topic particular. Okay, the theorem concept. Okay, next video meet again, next concept. Have a nice day. Bye.